Okay, guys, in this platform, we are going to consider our calculus, which is our differential calculus, the first part that you need to understand, which is the introduction to our calculus. So the major part that we need is to understand the average. The first part that you are gonna need will be on the average gradient, which is also going to affect us on the speed. So you're going to have the average gradient and also the average speed. So we're going to talk of this part as our major part of our uh, calculus, which is the introduction. So what is this average gradient, guys? Gradient does not change. You are given a certain cubic function, you are given a certain quadratic function, you are given a straight line. Gradient does not change. I want you to get back to the normal part that we had before when we were talking of a straight line. Remember, when you were working with the coordinate geometry, you are given two coordinates, x1, let us just say 2 points, which are just on a line, not just like the intercept, but there's 2 points which are on a line. Let's say we've got this point and also another point. This is x1, y1, and this point is x2, y2. Remember, how are you calculating the gradient? Referring the gradient as m, you're considering the change in y over the change in x. That is the concept. That is a change that is occurring in y over the change that is occurring in x. That is our gradient. Guys, that same gradient is still the same that we are calculating. What was happening at this condition? When you substitute the x value into the function, which is the straight line that you're given, maybe you're given y is equal to mx plus c. If you substitute a certain point, I want you to understand this from a straight line. Y is equal to maybe x minus 1. It's true that on a straight line, you can simply see the gradient there is 1. It's something that we can just take straight from a straight line. But I want you to see the concept that it is still the same thing, even if we are to consider this. We need 2 points. So you're just going to consider, okay, let's just say x is equal to 0 because a point is made from x and y. Remember, a point is taken from x and y. So just consider to say x is equal to 0 into this equation. What will be the value of y? So y is going to be 0 minus 1. In place of x, that's a 0 there. So 0 minus 1, that is going to be a negative 1. That is, we have the x value. We have the y value from the x. Consider any x value of your choice. Let's say when x is equal to 2, just any value of a choice. You substitute here. So y is going to be what? 2 minus 1 in place of x. So 2 minus 1, that's a 1. So meaning to say, when x is equal to 2, it's a point that you're going to consider. When x is 2, y is going to give us what? A 1. We've got 2 points that are taken from a line. And when you calculated the gradient, just like the previous case that you had, the gradient, which is or m is equal to the change in y over the change in x, you consider this x1, y1, x2, y2. We are going to see that when you calculate this gradient, you must get the same answer of a 1. The change in y over the change in x. That is going to be y2 minus 1, y1 over x2 minus x1. Or you can write as y1 minus y2 over x1 minus x2. Still one and the same thing. All right, let's substitute. The y2, that is 1, minus y1, what is corresponding to y1 there is a negative 1. So it's going to be like this. Over x2, that is x2 minus x1. Our x2 there is 2. So that's x2, which is 2 minus x1, which is a 0 there. So we are having our x1 as a 0. Okay. Let's consider this. Using your calculator, you're going to have plus and minus. That's a 2 over a 2, which is a 1. Guys, as you can see, that is the same gradient that we had on a straight line. We had that. So this is a straight and exact gradient that you're obtaining, which is the same. On a straight line, gradient is the same. But now when you consider a quadratic function, a cubic function, any other function which is not a linear function, the concept now is going to change of the gradient. The concept of the gradient is going to change. That's why you calculate what is now referred as the average gradient. Why are we considering average? Okay, this is the concept. Average gradient. So you wonder why are they not saying gradient? Why average? It is because when you consider a quadratic function, let's just take a parabola. I talked about this on the introduction, how to sketch a parabola. So I just hope you understand this. Let's say we've got a parabola of this nature. The concept of a parabola or any other function that you're given, it is a cubic function that you have, it is an inverse function that you have. It is not a straight line. So the gradient is not the same as on a straight line. On a straight line, the gradient is the same. That's why we just take it even from the equation y is equal to mx plus c. M is the gradient. We are not going to have a condition at this point. That is why we talk of the collinear concept. Okay, I want you to know this so that you do not have a confusion. These 2 points, if you use these 2 points, you obtain the same gradient with someone who used these 2 points. You obtain the same gradient with someone who used these 2 points. You obtain the same gradient with someone who used these 2 points. On a straight line, the gradient is the same. But this is different now on a parabola. Taking this point and this point, the gradient in between there is not the same as what we're going to have. That is the average, the gradient at any point is at this point here. If you draw a straight line, you're going to have a gradient. At this point, another, at this point, another. So the steepness, which is the gradient, the steepness of this function throughout is different. It is not the same. The steepness, how this function is flowing, is not the same. It is not increasing or decreasing in the same way. A straight line, it increases same part. It is increasing the same way. That is, the gradient is the same. It is decreasing the same way. The gradient is the same. But in this case, it is not the same. So that's why we consider the average gradient. So the average gradient now, as what we need to take it from the 2 points, you'll be given 2 points to consider on a function. So let's say I have got a point here. I have got a point here. So the average gradient will be taken in between. Okay, let me just consider somewhere here so that can understand somewhere here. So it's going to be like this. We consider a straight line drawn passing through these 2 points that we are given. So let's say this is our x1, y1, and this point is x2, y2. It means the average gradient, which is the change in y over the change in x, is still going to be the same. So in this case, this is the formula that we are going to simply use whenever we are calculating the average gradient. But what I wanted you to know is that it is not the same as what we had on a straight line. There is nothing like average gradient on a straight line. It's just a gradient because the gradient there is the same. But when you consider a parabola, you need 2 points to consider an average gradient between those 2 points that you are given, but the calculation is still the same. If I have got these 2 points, the change in y over the change in x. So you might be given those 2 points, or they might give us only the x values. If you're asked to calculate the average gradient between, you must be given 2 points. Maybe you're given between x is equal to 1 and x is equal to 3. These are only x values, but we need a point. So from the x value, you must substitute into the original function to obtain the y value. And also from this point where x is equal to 3, you must substitute into the original function to obtain the y value. Then you can determine your gradient. So you're going to work with this using typical questions that we might be given on the average gradient. But like I said, what you need there will be 2 points to consider. You cannot work from a single point. What you need will be 2 points that you are going to calculate the gradient from, or to determine the average gradient from. Let's say we are given, just going to consider an example. Let's say we are asked to determine the average gradient. Let's say we're asked to determine the average gradient. All right, sorry for this, guys. I did not write these questions earlier. I'm just going to try and write it here. The average gradient, okay, of a line of a line through the points you are given, the points 2, 1, and 4, 9. Okay, on the curve or on the graph, so it can be a curve or on the graph. So you're given on the curve y is equal to x squared. So actually, you are not supposed to be given as points like this when you are to calculate this gradient, because they must give you as the values that you're given. Like when x is this, y is going to be this one. All right, when x this value, then y is going to be like this. That is the concept that you are supposed to work with. All right. So in this case, these points, guys, these points are actually wrong. You can't determine, you can't have these 2 points from this line. This was supposed to be like this. These guys also, when they are setting this question, they don't revise. 2 squared is supposed to be a 4, and 4 squared is supposed to be a 16. So the question was supposed to be given like this. We cannot have the average gradient of a line of the points on this curve having 2 and 1, guys. This is the curve. Remember, this is the curve of y is equal to x squared. So when x, this is the x value, this is the y value. So when x is 2, it must be 2 squared. So y must be a 4. When x is 4, it's supposed to be 4 squared. So y is supposed to be a 16. So you see, guys, these guys, they are saying they are having new revised textbooks, while the revised textbooks are not yet revised again. So they need to revise again. So our department still needs to revise their text again and again, because what they call a revised has to be revised again. So I don't know, guys, what is happening. Anyways, let's see. So that is what is going to happen in this case. We're going to have something of this nature, our x and y. So I just want you to see like the consideration of what is going to be like. But once these points are there, there's no need for even you to have a sketch. But considering the sketch of the graph of y is equal to x squared, this is a quadratic function. Remember, we talked of the format of y is equal to ax squared. This is a graph that is going to pass through the origin, having same values, like the values along the x are the same that we are going to have along the y, symmetrical about the what? That is about the y-axis. That is the concept. Along the y-axis, this is the line of symmetry, which divides this graph into 2 corners. When I was talking about the x value, I'm saying to the negative values, the y values are the same. To the positive of x, the y values are the same. If x is -1, y is going to be a positive 1. If x is 1, y is going to be a positive 1, because you are squaring the value that you're given. So this is what I was saying. Along this curve, you cannot have a point such as 2, 1. When there's a point 2, guys, along the curve, when x is 2, on this curve, it can't be, because you must square it here. So 2 squared is supposed to be a 4. So y there is supposed to correspond to a 4. All right? When x is equal to what? To a 2. Y is supposed to be a 4. So this point here is the one that you are referring as 2, 4, which lies on the curve. The point is not lying on an open space. No, the point must lie on the curve that you're given. So the same thing, if you consider the second point, that is 4, 16. Let's say there's a 4 here. It's going to correspond to 16. Okay, let me just put it somewhere here. So let's say a 4 is going up here. It must correspond to the y value being a 16 on the graph, on the curve. The y there is supposed to be a 16. So meaning to say we have got 4, 16 like this. Okay. So this is the presentation that they are simply talking about, guys. Find the average. There is a straight line that you must draw passing through these 2 points like that. It's a straight line. So that is why we're talking of the gradient that is going to pass through these 2 points. But the line that we have, it's intersecting. The line that it is intersecting with the curve. It's like this. You have a curve, then the line is on the curve. So the points lies on the curve, they also lie on the straight line. So they must maintain the properties of the straight line and also the properties of the curve. What are the properties? for every x value that we substitute into this, it must correspond to the y value. All right. So with this, guys, you can determine your gradient. So you can determine your gradient. Actually, like I said, when given the point, because if they make a mistake like what they just did on this example that we are talking about, if they make a mistake like that, you're under exam. They will give you 2 points. Just work with those both. They are going to work with those 2 points that they gave you. So they are going to work with those. So you just work with those 2 points. But this is for revision purpose. This is supposed to be the right thing. All right. So with the points that we have, we can calculate our average gradient. Remember the gradient, the change in y over the change in x. So meaning to say that will be from our points, we've got x1, y1, and that will be x2, y2. So let's substitute and see what we're going to have at the end. So the value of y2, that is 16, minus y1, which is a 4, over x2, that is our x2 here, that's a 4, minus our x1, which is a 2. So you can simplify this direct on your calculator, that is to determine the gradient of the 2 that you're given, which is going to be something like a 6. So meaning to say the average gradient on this curve from the 2 points which lies on the curve is going to be a positive 6. So that is the concept that you are given. The points that you are given, they are supposed to maintain the properties of the function that you are given. It is supposed to lie on that function that you are given. So it's supposed to also maintain the same properties. So this is what I want you to understand, because sometimes you might not be given exact points like what you are given here. Let's say we've got another question. So I want us to consider another question here. So as we are revising, guys, also be careful of your textbooks and how they are presented there, because they will be saying it's a revised part where also it needs to be revised again. So that's what we have actually on the ground. So we just have to work with that, but also knowing what is the right thing in the simplification. All right. So there we are given, again, we're going to have another question. Determine the average gradient of, so let's say we are given y is equal to 3x squared plus x minus 2 between the points. So this is what I want you to understand. That's why I'm bringing that part again, between the points with x values. So the x values sometimes will be given, that is the abscess. So if you consider this, that is the abscess, something like this. All right. So guys, so consider that why putting yourself in those big terms. If you're given just the points with the x values 1 and 3. Okay, this is what I want you to understand, guys. You are given the x values, and these x values must lie on this function. These x values must lie on this function. So in the previous case, guys, I showed you from the sketch. So there is no need for you to actually have a sketch. What is important is that, look there, it's just x values. So these x, where do they actually think you're going to obtain the y values? Because for you to have the gradient, you must have x and y. Remember our formula. They know that these x values are on this function. They lie on this function. So we are going to substitute. When x is equal to 1, what is the y value? So y is equal to what? Into the original function. 3 into 1 squared plus a 1 minus a 2. So that's why I was talking much about the first example that we had, because it must be from that function. So y there is supposed to be equal to a 2 if you substitute properly on your calculator. Then you do the same. So it's actually a point before you continue. X is 1, y is 2. Remember, a point is made of x, y. So x is 1 when y is equal to what? When y is equal to 2. That's where we've got a point from there. The same thing you're going to consider when x is equal, because we have got the x value, which is 3. When x is 3, substitute into the equation, into the function, 3 into 3 squared in place of x plus a 3 in place of x minus a 2. That is, you must substitute everything that you are given in place of x. So you have to simplify each and every part that you are given there. That was going to be something like 28. If you substitute properly, that is what you're going to have. So meaning to say we have a point there, just like the previous case. When x is 3 from our function, y there is supposed to be 28. So there we now have to consider the 2 points. These are the 2 points now that we have to consider in determining of our average gradient. We have got the 2 points. So remember your formula. So you're going to need our points, then our average gradient in that case is going to be given as what? The change in y over the change in x. So that's it. So you're going to substitute the change in y, that's y2, which is 28, minus y1, which is 2, over x2, which is 3, over our x1, which is 1. So we can just simplify this from our calculator, or you can subtract this. That's a 26, and this is a 2. So meaning to say there, we are going to have a 13. So the average gradient is going to be equal to 13 of this function. So if you consider this now, then go back to the first question that we had when we were given the function of y is equal to x squared. Then a textbook there, it gives you a certain situation or a scenario when they are saying x is 2 and y. This does not make sense because the x value that was substituted there is supposed to determine the y value at the end. So consider also your revisions, guys. Do revise also as an individual. Make sure that you go through a lot of revisions that you can consider in the simplification. So you're going to see that about this average gradient, we can write this as a formula that we are going to actually use later on when we are going to talk of the first principles concept. There's a formula there that we are going to use later on, working with the derivatives from the first principles. But this is what I want you to understand. This formula can be adjusted because there is a change in y that is happening from a function. Let's say we are given y is equal to f of x. We can also have this change that is happening, the change that is going to happen in terms of y and x from the formula, which is given as f of a plus h. So let's say we consider with a and h, or x. If you consider f of x, you're going to consider this as f of x plus h minus f of x over h. So considering that x is represented by a certain value, x is represented by a certain value, which is a. So this will be f of a plus h, and this is going to be f of a. So I'm going to explain this part later on when you are considering actually the part of your functions. But they might give you a question like this, where they want you to determine the average gradient. Okay, let's say you are given a question like determine the average gradient of the graph. Let's say we are given something like this of the graph. Let's consider this question. Let's say we are given f of x is equal to x squared plus 2. All right. So remember, for you to have an average gradient, you must have corresponding points. You must have corresponding points. All right. So there we are going to be given the points where the average gradient is taken between these 2 points, all right? So the average gradient taken, average gradient between the points, so it's going to be taken between the points, all right, and these points are given as x. So this is the condition. If you have x like this, it means y, because you're supposed to have x and y. Remember, a point is supposed to be x versus y. So if you are given like this, f of x is y is equal to f of x. That is what it means. So what represents y is f of x. So if we have got an x here, this is f of x, which represents what? Which represents y. So y in this case is simply going to be taken as f of x, because they might not give you this f of x. They might just give you x. You must know where they are taking this f of x. So if what I'm trying to say is that, remember, if you substitute a 2 here, it means f of 2. In place of x, you're going to substitute a 2. So when you are given x, it means we substituted x as it is. So that is f of x, which represents y. But let's say you are given, because that's our first point, and the second point, they might give you that point as x plus h. So let's say you're given x plus h. What is going to be representing y? Because x is given as x plus h. What about y? Remember, y is taken from f of. From the previous case, it was the f of x as it is. But this time, it's not going to be f of x, because we have the part of x now. Look what is happening. Where we are given x, what represents x is now x plus h. This is what is representing in place of the x that we had before, as it was there. It was exactly x. That's why we are writing f of x. But now what are we having? X plus h. So it means in place of this, we are going to have x plus h. So y is equal to f of x plus h. So in place of this y, instead of them giving us the exact value of y, now they will give us that value as f of x plus h. What you simply need is to understand what it means. That's the y value. When you substitute this, that is what it means. So you can simply use that formula that we are given, guys. The change in this part does not change. This is your x1, this is your y1, this is your x2, this is your y2. But as we can see from these 2 points that we are having, this is f of, they are not giving us f. It's f of means what we are seeing here. That's our f of x here. So it means the exact point that if we are to get rid of this is what we're going to have, guys. That's our solution here. This x that we are seeing is the x value that was substituted here. And by substituting x, we are still having the original function. That's why we are writing as f of x. We are still having that original function, which is x squared plus 2. We still have, that is our f of x, remember? So we still have the concept there. That is our y value. Y is equal to this. So it's a point x, but y is not given. There we are not given exact values. Like, remember what we were given before. When this is a 2, you substitute a 2 here. So when you are given it as an x, where there's x, substitute x, what's going to happen? There's nothing, guys. X is squared plus 2 like that. It's going to remain as it is. The same concept, that's another point. When x is given as x plus h, if our x is now taken as x plus h like this, what is going to be the y value? Because we need a condition where we have got x and y. So it means the y value in this case here, the y value here, is the value that we are going to obtain when we substitute this. Just like when you're given a 2, you substitute a 2 here. So it's going to be y is equal to 2 squared plus a 2. You obtain the y value from there. The same concept that you had before. But this time, we are not given a 2. We are not given a 2. No, we are given x plus h So you must substitute as it is. So it means y is equal to, this time, the y value that we need here is when you substitute your x as what? X plus h. So where there's an x here, where there's an x there, you are going to have x plus h squared in place of the x. You substitute what you're given. If there is a 2, you substitute 2, just like when you given what we had before. But there is also a plus 2 there. Plus 2, there is no x here. We do not have x. So there is nothing that we are going to substitute on this part. So as we simplified, guys, this is the value of what? This is the expression for y, just like what we had. Y here is x squared plus 2, because x is what? X is x. X is just x. There's nothing that changed. But here it changed. X is now taken as x plus h. X plus h. So we can expand our brackets, guys. So y is equal to, let's just try to simplify this. So remember that from the expansion of a plus b squared, which gives us a squared, plus 2ab plus b squared, which is the first term squared. So we're going to have this as x squared plus 2ab, which is 2xh or 2hx, whatever the way that you want to write it. You can write it as 2xh like this. You can write it as 2hx. The presentation there is in your hands. All right. So that is what you're going to have. Then we are going to have plus b squared, which is the last term squared. So that will be h squared. Then this is taken to be what? This is to be taken to be a 2. That is the condition that you are having. This will be taken to be a 2 as it is. There is nothing that you're substituting there. This is just a 2 as it is. This is just a 2 as it is. So I want you to consider now to say from this, the value of y that we have, we can write this as a point. So there are so many ways that you can present this. I just hope you're going to understand this one. So that will be x squared plus 2xh. So this will be 2hx or 2xh plus h squared plus 2. So this is representing the value of y that we are given. So we are supposed to use the change in y and the change in x. But since we have got a certain letter h, which is considered and not to be part of our expression, not to be part of this function that we are given, we are going to use the concept that we had here. That is, our average gradient is equivalent to this formula. So I want you to see this formula where h is. This is our formula. I want you to see what happened there, where h is. All right. I want you to see what is happening on our formula there. I was saying from our formula, the gradient, which can be written as m, or the average gradient, is given as f of x plus h minus f of x, everything over h. So this is what just happened here. The formula is direct and straightforward. What it simply tells us here is that we can obtain the gradient expression, not the exact gradient. We're going to talk of obtaining the exact gradient. We can obtain an expression for this gradient in terms of h. That is what we are given there. So with this, our f of x plus h was this part that we had, f of x plus h. Remember, when you substitute, this is the corresponding value, which simply represents y2. This, remember, our f of x plus h, when you substitute this. So you're going to take that f of x plus h that you simplified, which is x squared. All right, that's our f of x plus h. So you're going to substitute this. Let's say, so you're going to have x squared plus 2xh plus h squared plus a 2 like this, minus f of x. F of x is the part when we substituted that x that we had, and our f of x was what? That corresponds the y value, x squared plus 2. So you're going to subtract x squared plus 2. That's our f of x. Everything over what? Everything over h. All right, so let's simplify further. Then we're going to expand the brackets, x squared plus 2hx plus h squared plus 2. Then you expand, that will be minus x squared minus 2, everything over h. Okay, so I want you to see something here. X squared and x squared can cancel. The 2 and the 2 can cancel, meaning to say you are obtaining, or you are left with the 2xh plus h squared like this over h, which we can reduce because we can see that h is common there. Remember, a plus b over c can be given as a over c plus b over c. We can separate these terms, a over c, b over c. So it's the same thing that we are given. We can separate these two terms over h. 2hx over h plus the h squared over the h. I want you to see what's going to happen here. So that's going to cancel, and we've got 2x plus this one and this one. You are remaining with h. So this here is not exactly the gradient that we are supposed to have from the normal part that we need in the simplification. But it is giving us an approximation of the gradient. So what is going to happen is that for us to obtain the exact gradient expression from what we are given, this one, this is going to be taken as, which, like I said, I'm going to talk about this from the first principles as a complete formula. So for you to obtain the exact gradient expression, we need the gradient expression, or just the gradient term. It can be an expression or it can be a term. So for you to obtain the gradient expression or the term, which is the exact gradient there, what is going to happen is that you are going to limit your h to be 0. You limit your h to approximate to 0. So if this h here is approximating to 0, it means our average gradient, or the exact gradient that we have at that condition, will be given as 2x, as h is approaching to a 0. All right. So I want to conclude this as the exact average gradient expression, which we are going to refer on a separate part, is simply taken as the first derivative of x, or dy dx from what we had. We're going to talk of the first derivative. As you consider the approximation of h to 0, it's now a derivative that you consider there. So we're going to talk of the derivative later on, where we talk of the h approximating to 0. So we're going to have the limit as h is approximating to 0 of f of x plus h minus f of x over h. So here we just applied this formula by disguise. We applied the same formula by disguise. If you check, we applied first, what is it that we had? The gradient, the average gradient is taken as what? The average gradient is taken as f of x plus h minus f of x over h. You substitute, like I said before, then you obtain this in terms of x and h. Then to obtain the exact gradient, we're going to limit the h to 0, where you obtain 2x as the exact gradient expression, or the gradient term that you are given, not like the exact value. The exact value will be given now when they're saying when x is equal to 2, when you're given when x is equal to 3, you substitute there. There you now obtain the exact numerical value. There's a difference, remember, between an expression, a term, and the numerical value. When you consider the numerical values, you are now having the exact number that is corresponding. When you are given that x is 2, you substitute there, 2 times 2, it means the gradient at that point was f4. You're now obtaining the gradient at a certain point. So that's another part that we are going to refer to, which is on the what? On the average gradient. So this is it, guys. There's nothing about average gradient. They will just try to confuse you there when you are given a condition of that nature, where they just want you to get confusion, this and that. So like I said, we've got the gradient that we are going to consider, the average gradient, and also to consider the average speed. The average speed. So I'm just going to finish up this one so that we have another class that will consider now working with the exact derivatives that you are given. So the average speed, guys, is simply the same thing. Remember, if an object is taken from our engineering science, we do understand that the displacement can be given in terms of t, a t squared plus bt plus c, like that, which is simply the same situation or presentation of a quadratic function. Y is equal to ax squared plus bx plus c. This is what we had before. So it means we do not have the exact value of a speed. We have got what we refer to as the average speed. So as we can see, it is the same shape that we are going to have. This is t squared, just like what we had, ax squared. So we still have or consider a parabola. So whenever you talk of this, it can be given from a parabola. It can be given from a linear function, depending, like what I said before, if you are given a linear function of the sort s is equal to vt, like this, where this is the velocity representing the speed. That's a linear function. On this case, you draw a linear function, a straight line. But once you're given this at squared bt, like that, that's just like a quadratic function. So it means your function is just going to have the same concept, just like what you had on a algebraic function. Then you consider 2 points again. So here, I'm not going to waste much time. I'm just going to talk about finding this average speed. So when given a function, just like what we saw, we need to have the 2 points that we are going to substitute into the function that you are given. You are going to need 2 points, okay? The 2 points that you are given, this time, they are not giving us the x values or the y values. Now we are not talking about the x values and the y values. We are talking of the speed that you are given, that you gonna consider. So we can say the average speed or velocity, all right, which is the speed. All right, let me just have it here. So the speed or velocity, which is the average speed in this case. Let's have it as the average. Remember from the previous case that we had, we are having y, but we are not going to have y, guys. Remember, it is s written in terms of t. So the actual way it was to write, like, remember, if you substitute this t, you're going to obtain s. So you must have t1, s1, and you must have t2, s2. So this situation is fine for us to have, but in most cases, you guys, you tend now to have confusion when dealing with these two. So what I can just advise you is that you can use this in terms of s, or you can use in terms of y. So let's write in terms of s. We're supposed to have this as s2 minus s1 over t2 minus t1. This is still the same way like what we had before, guys, like in terms of y2 minus y1, what we had before, y2 minus y1 over x2 minus x1. But on a displacement graph, it's the displacement versus time. Displacement versus time. So you're going to have time versus time to displacement, time to displacement. So if you have got as points, this will be T1. So this is just like what we had on calculating the gradient, guys. Are we seeing that? It's the same formula of our gradient, but it's just written in terms of what? In terms of S. So you can even, if you understand the Y concept, just use the Y concept that you're given. So when you are given, let's say we have got an object which is just given on a linear function. This is when you are given that part of like a quadratic function. So on a linear motion, consider a linear motion. Remember from our engineering science, there we talk of the linear motion where the object is to be given when we are referring the displacement, but being taken from a straight line. So here you'll be given your displacement and you'll be given your time. So let's say an object is taken this way. You are going to see that we are forming a straight line in that case. You are forming a straight line, like what in this case. So the straight line is just going to be like this, guys. The t corresponding to s. So if this is t1, this will be s1. The same thing, if this is t2, then the corresponding value there will be s2. So that is simply the change that is happening. The change. Velocity is the change in displacement over the change in time. So the change that happened there, S2 minus S1, which is the same thing that we have, S2 minus S1, over the change in time from T1 to T2, what will be the change? That's T2 minus T1. The change, maximum minus minimum, maximum minus minimum. That's where it was taken from. So when you are given this, guys, be careful. Okay, be careful how to present your formulas. It's not like a much difficult thing to consider on that other concept that you are given. So I'm just gonna refer just typical examples, but as you can see, guys, everything there is direct. Once you are given the points that you are given are the points that you are going to use in determination of what? Of the average gradient. All right. Of the average speed, which is the same as the average gradient, actually. All right, which is the same as the average gradient. So sometimes we might, okay, the change in time. Let me write this way. I want you guys to understand this. This is simply representing the change in the displacement over the change in time. All right. The change in displacement over the change in time. You have that. The change in displacement over the change in time. There you are given time and displacement. All right. So before this, all right, let me have an example. Before that, I'm going to consider both. There's another formula that mostly, guys, you use, which is not like a problem. But it has conditions where we are using it. There we are given displacement. Guys, displacement. This is displacement, like distance. You are given your displacement. All right, let's say we are given to determine the average gradient given a function. I'm just going to consider this one, determine. So let's say you're asked to determine the average gradient, the average speed actually, of the displacement, or let's just say of the distance time graph. And you are given that as s is equal to t squared. So I want you to take this function minus 4t plus 3. So you might be given a function like this, where this s is the, where you are given, I'm going to talk about this, s being the distance, which you can consider as the displacement, and the t being the time. So you can also be given time, like let's say in seconds, distance in meters. They can give you that, which is fine. All right. So what is important is that for you to determine the average speed of this distance time graph that we are given, we must have the times that are corresponding. So you might be given between t is equal to a 2 and t is equal to a 4. You are given the values of the time. The time is the one that you are given there. And from the time, remember, it's supposed to be a point, like I said before. So guys, I'm not going to draw this function like so sketch, guys, because of time. I'm just going to refer, because the same as the previous case when we are considering those algebraicas. Look at the shape, everything is the same. But what you need on the points is time versus displacement that you're going to have, or time versus distance. When you substitute the value of t, you obtain s, just like x and y. Remember, when you're given y is equal to x squared minus 4x plus 3. Now they just changed. This is t, this is t, this is s. What was happening before? If you substitute an x value, if x is 1, you obtain in place, like you substitute in place of x here. When x is 1, you substitute in place of x. What you obtain is the y value. So it's the same thing with this part that we are having this time. When we substitute these t values, we must have their corresponding s values. So just like the previous case, when t is equal to 2, so what is the value of s? S is equal to, in place of t, so you're going to have 2 squared minus 4 times 2 plus a 3. So that is going to give us the value of s at a condition, take note, where t is what? Where t is a 3, where t is a 2, so that s was going to be a -1. So it's a point, as we saw, a point t versus s. So our t is 2. So there we have got a point 2, and our s is -1. So it's just like we have got point t1, s1, just like xy. You do the same thing. So there's even no need for you to sketch this. You do the same thing, guys, on a condition where t is equal to 4. So you're going to consider when t is equal to 4. You substitute that into that original function. So that's s is going to be 4 squared minus 4 times 4 plus a 3. So you're going to say that your s there was going to give you a 3. So it's a point, t versus s. So t is 4, and our s there is a 3. When t is 4, our s is 3. So that's why we've got a point, t2, s2. So we can determine the average gradient when it is like this because of what we have. So the average gradient can be taken from the points now, which is our average speed, can be taken from the gradient concept. The change in displacement over the change in time. So it's going to be s2 minus s1 over t2 minus t1. So you can substitute just like the previous case. S2, that is 3, minus S1, which is -1 over T2 minus T1. So our T2, that's 4, minus T1, which is 2. So that's it, guys. It's going to be 4 over 2, and that's 2. So this is speed. And remember, speed must be measured in meters per second. That's why you're given the distance there, meters, the speed, the time in seconds. So the speed, average speed, is meters per second, or it can be given as 2 meters per second, like this. Still one and the same presentation. So given the time, the presentation like this, where you have got the displacement in terms of time, you must substitute the given values. Calculate the average speed between the time 2 and 5. Given a certain function, substitute those values 2 and 5. Calculate this between this point and this. You substitute those 2 points that you are given. So it's just a matter of substituting what you are given when it is like that. All right. There's another part where you are just given if the speed is measured at 2 different instances. You are given speed. This time, they were not given speed. It was displacement, guys. Take note. You were working from displacement. Whatever that you were given there, you were working from what? From a displacement. So we might be given a condition of the average speed, the same average speed that we had, which is the same calculation that we had of the average speed. But now consider that we are given two speeds. All right. So let's say if the speed is taken or is measured, so it can be taken or is measured at two different instances, So we need to consider that at two different instances. What is going to be our average speed this time? There is speed. We are already given speed. Not there. It was calculated from displacement. We're taking this from displacement and time that you're given. We were taking this from displacement or distance. And what? And time. There we are given speed, guys. You are not given like the displacement, this S in terms. No, it's already under speed, but only that the speed is given at different conditions, at different instances. So in that case, your average speed is just going to be the sum of the two divided by 2. So our average speed is going to be simply speed 1 plus speed 2 over 2. That is, if you're given in terms of velocity, you add the velocities that you are given there, then divide by 2. The speed of a body after 3 seconds is 18 meters. And after this, you are given two speeds that are different. A speed of maybe 8 meters per second, and another speed is given as 12 meters per second. They are taken between two different times. They are taken between two different times. This is not like we are to calculate the speed. No, we are to calculate the average of it. Already it's a speed, this one in meters per second. This is not distance or displacement. It's already in speed. So whenever you're given like that, no matter the time that you are given between t, which is 3, and t, which is 20, that does not matter. The average speed, when it is like this, is the sum of the two divided by 2. So the average speed, I don't even need to know about the time. I don't need even to know about that. So the average speed is simply going to be speed 1 plus speed 2 over 2. So that's it, 20 over 2, which is going to be 10 meters per second. So that is going to be your average speed when it is like that. So they might give you as velocities, velocity of this to the velocity of this. You still use the same concept, that velocity plus that another velocity, then you divide by 2. That is the condition that you might be given. So like I said, the average speed can be taken from a certain function between times when given from a certain function, which is the distance. You must consider in terms of time. They will give you this distance or displacement in terms of time. Maybe you are given S is equal to t squared minus t minus 1. You must be given the time between the moment that they are saying and the time is 0 and 7. Maybe you are given your times as 0 and 7. This is the time that you're given. There you have to substitute. When this t is as 0, you substitute in place of t. You obtain the value of s from there. When t is a 7, you substitute, you obtain the value of s from there. Using the exact value, you determine your gradient. So you must substitute into the original function. Whenever you're given a function, you must be given two corresponding what? Two corresponding values that you use. But on this one, it's already under speed. It's already a speed that you're given, a speed of this and a speed of this under a certain period of time. You just find your average gradient by what? Adding the two speeds or the two velocities they might give you in terms of velocity. Then divide by 2. That's the average speed or the average velocity. So you're going to have a continuation. I didn't expect that our introduction of these average values is going to be like this. Okay, guys, no way. Okay, no problem. Let's consider, we're gonna consider next class working with other part of our differential calculus, working with our calculus.